without crashing or showing errors, especially during the lessons, because my son will be totally like clueless what happens. I mean, right? So if I keep it dust free, if I keep enough disk space, and if I have a proper power supply, the stable power supply, I expect it to work without crashing. But what happens if there is a manufacturing defect or a security vulnerability? We have to download a patch, or to hide the fact they call it a system update, right? So we have to spend our bandwidth, time, data and everything, download it. And sometimes, I mean, for those who are familiar with Windows, you can't sometimes actually say no, don't download it at this time. It just downloads, so you have no control over it. So it's totally at the cost of yourself, right? So the user's cost is big, but for the company it's very negligible, because they can fix it like something and then bundle it and send it through the internet. So because of ecosystems like this, sometimes certain companies have a policy or a practice, would say, it's not probably like an advice as policy, but they will tend to release software without completely doing the exhaustive, extensive testing that they need to do. They can always say, we can always do a patch after the release, because it's very, very, the cost is very marginally low. So there is a disparity if you compare these two graphs. Right? So this comparison is quite common, people do this, and there's a fair side to this as well as a not so fair side to it. So let me come to that. Generally, the claim people make is that they compare these two products, a software and a car, and they say the software is inherently less reliable than a counterpart, car. But the way I see it is not really an apples to apples comparison. So let me go into details. Before that, why it's not fair, let me take you through a few of other questions that will help you to understand. So how often does a new car model gets released? If it is a popular model, it's usually once a year, right? 2019 model and 2020 model. And then how often an OS gets released? Probably once a year. Something very popular could be like twice a year, or something could be like 2-3 years at a time, right, between releases. But what about business software? How often do they get released? Sometimes monthly, sometimes weekly, and sometimes even days. So why do we need these releases, frequent releases? So the releases are needed because there's some sort of a change. So let's look at the changes. For a car, when would the requirements change? Pretty much never, because there could be new fancy stuff coming in, new looks, new gadgets, new luxuries, but the main goal of the car remains the same, transportation. So unless the cars stop going on roads, there's no real need to change the core of a car. Right? So what about OS, software like OSs? Again, the requirement changes pretty much never. It may get new looks, it may get new bundle software, now fancy stuff, but the main goal remains the same. That is, abstract the hardware. And unless the underlying hardware architecture changes, there's no real reason for software like OS to change. But what about the business software? So as the COVID lockdowns began, we saw like a huge growth in remote collaboration. Everybody started working from home or other places, like they couldn't come to the offices. So remote work was a big thing. And then with that, remote communication. So the tools like Zoom, Google Meet, all these things came into play. Audio, video calls, and there was another like a huge influx of non-tech savvy users, right? Because like we have been using, like as software engineers and like people in the IT industry, we have been using these tools for some time. But there are a lot of people who are not really familiar with, especially people who are working in like schools, right? For example, if you see how these teachers conduct the online sessions, I mean, some of them haven't even touched a computer for quite a long time, but they have to adapt quickly, right? But with that, the software needed to change as well. So the software has to be very user friendly and very intuitive, and should be foolproof as well, because people might click the wrong button, people might do the wrong action, so it has to be foolproof. So it should be so obvious that you need to click this one, and also if the user does something by accident, it should allow them to recover, right? So the software might come with user manuals, but when was the last time you referred to a software user manual before you actually tried something? And also they had to adapt to new hardware devices. Like people started connecting from mobile phones and tablets. Like if you see that a lot of these online classes from schools are actually conducted through mobile phones. Teachers have mounted their mobile phone somewhere, and then they actually in front of a whiteboard and they do the session. So the devices have to work. I mean, they have very limited capabilities hardware. So low resolution cameras, maybe low-fi microphones, all these things, software needed to change to adapt to that. And also the business models have changed. For example, the supermarket chains like Cargill's, Kiehl's had to actually change their solution, and they had to cater to online ordering. Some of them like provided this facility to like through some of the outlets, but not throughout the country, but they have to change. They have to make the system scalable so that they can accommodate a lot of online ordering as well. Right? So, I mean, all these changes were quite sudden, quite drastic. I mean, some of you are already familiar with how the GDPR changes came in, right? So it was a very phased approach, and there was a grace period, and we had time to test certain things, try out certain things, verify and all that. But changes like this, the COVID lockdowns, are not like that. So we didn't have enough time. I mean, like everybody's in a rush. So it was like a change or die situation, and actually some businesses have died because of this. They couldn't adapt fast enough. So do we like when you look at certain software like OSs, they are stable, and we can really complain saying that okay, that's not fair, that the software like OSs are actually not that reliable as cars. But if you look at business software, we can't say that, because it's not apples to apple comparison. They need to change weekly, daily, or even like could be like within hours sometimes. So should we just accept for what it is and then try to live happily? I don't believe so. So there are things we can do, and so let's try to look at this as a problem and see how we can solve it. So if you look at OSs, they are on one side of the spectrum. So they have very predictable releases, stable requirements, and between releases there's ample time for the tests to be done before the release. But if you look at business software, they are highly dynamic, could change every day, and the changes are coming fast and very frequently, and like time to test before release very small, and we need to do everything to make sure that we release a software without faults, because it could be a cost for the company if the software breaks. So people want reliability. So in software terms, if you look at how we define this, I will define it like the ability to rely on the software the people purchase to get the work done properly. So it's not that the software works, but it has to do the work properly. Right? So that's where this cost versus software less reliability comparison comes in. But let's see what we can do to improve this reliability, right? So if we want to improve the reliability, so the general claim is not reliable. So let's try to address that. So if we want to increase the reliability, first we need to measure. What gets measured gets improved. So once we measure, we know where we are, and then we can try to do certain things to improve. Right? So let's try to look at a very abstract strategy of improvement. So let's say we are trying to count the number of times the software breaks. So by breaking, I mean like it's not going to work, it's not working as expected or intended. And let's look at how we can develop a process around it. So what we can do is we can subject our software we are looking at to different circumstances. So the circumstances could be different inputs, could be different resource allocations, different configurations, like where you deploy, how much network activity you have, and the resource allocation. For example, it could be like the memory you allocated for this application, could be the hard disk size, could be the CPU power of the machine, anything, right? And then things like the number of operations requested, or in other terms we call it load, right? And then we can like after applying different circumstances, we can look at how this software breaks, and also count the number of times. And also while we are doing it, we can actually identify the circumstances that led to the break. Then by looking at these parameters, we can prioritize. So we know, okay, this breaks something, and then we prioritize how important is this particular behavior, how important is to work in a low resource allocated environment. And based on that, we can prioritize these issues to identified issues and then fix it so until we come to that desired level of reliability. So we need to understand what is the desired level of reliability we want. So normally we will not usually go for 100%, but we try to come close to that. Depends on the software and the application. So let me define a couple of terms to go forward. So I'll call the act of subjecting a product or software to different circumstances artificially in a controlled environment as testing. Right? And a single occurrence of such an act I'll call a test. And the documented procedure for such test I call a test case. Right? Just simple terms. I'll be using these terms in future session. Right? So to increase the reliability, what we'll need to do is do more tests, measure, and then improve. So let's come back to the question of cars versus OSs and other business software. Right? So when you have sparse release cycles, you have enough time to test things. So cars and OSs should actually be more reliable in the long term, and like we expect it to be more reliable. But business software, we have very short release cycles, and it's very challenging to plan and test because of these short release cycles and the time pressure and the complexities. So we are trying to look at how we can improve this further. So there could be a couple of solutions. So let's try to go from one by one. So what we can do is we have people who are familiar with the testing, and then we can employ more people for testing. So it's like an ever increasing army of testers as the software grows, as the complexity grows, and probably as the business value grows. Right? But there are a few problems with it. There are obviously human errors, and then when you are doing certain things repetitively for a long time, like you tend to get dissatisfied with the work you are doing. So job satisfaction is going to be a big issue, and also human resources are very costly. So it's going to be a very huge cost. Another alternative we can look at is outsourcing. Right? So we can actually outsource the concern about these human errors and the job satisfaction to outsourcing companies and get our work done. But the way I see it, we are actually trying to trade one set of problems for another set. Right? Yes, we will have less human errors and less problems with the job satisfaction, but we will need to increase, like we'll have more of the documentation and training needs, the management overhead, and probably the cost. Because the companies charge a margin on the work. And also, like if you have very specialized training done for a particular outsourcing company, for example, you sort of have a lock-in, service lock-in, so you can't easily move to a different service provider for your services. So there are certain things, like up to a certain level you can go for these outsourcing solutions, but beyond so for small scales, yes, it will work, but if you go to medium and large scales, outsourcing is not probably a good solution. And also it can work as a temporary solution when you have a resource problem. For example, if you want to get something done very fast, but for a very short period of time, you can outsource the work, get it done until you figure out how to improve your human resources or come up with a different plan to tackle that for a longer term. So I don't see this as a very long-term viable strategy. A third option we can look at is test automation. Right? So the test automation is basically writing another program to test the software we are building. And if you want to increase the number of tests, remember we are trying to increase the reliability and how we measure the reliability. So if you want to increase the number of tests, what you can do is you can just go ahead and add more automated test cases. So it will help us cut down the time needed for testing, because we can then use more computing resources for this. We don't need to worry about having humans to do this. We can go for more powerful machines, so we can scale vertically, or we can go for more machines, which means scale horizontally, or we can do both. And computing resources are comparatively dirt cheap, and some services allow you to actually pay per use or like per hours or per minutes even. And it's very easy to acquire because like they are available on demand. But if you think about how to hire a person, like you know how lengthy the process is and how long it's going to take. Sorry. Okay. But there is a cost to automation. We need special type of people for this. So we call them automation engineers. So these special people are the people who can actually convert these test cases we have identified to programs. And why they are special? Because not everybody can do it. And once you have it automated, you need to maintain those tests. Because as the system changes, remember business software, it's inherently the nature of business software to change very fast. So you need to maintain an additional set of work, the automated test cases, to change with the software. And these are specialized people, so they need special skills. So it takes time to acquire the skills, and if we are looking for high skilled people, we need to give them higher compensation. So again, human resource problem, it's going to be very costly. Right? So it's not as bad as having an army of testers, but still it becomes a human resource problem. So is it like that we have like keep on bumping around to different dark clouds? It seems so, but there is a silver line. And the silver line you can see if you look at the problem in a different angle. So instead of looking at it as a resource problem, if we look at it as a strategy problem, we can see the silver line. Right? So the strategy here I propose is to look at how you do it in moderation. The right amount of moderation for the tests. So do I mean that we need to decide what aspects to test of the system and what not to? No, that's not what I'm saying. It's again like it's not a numbers problem, it's not a resource problem, it's a strategy problem. So it's not the number of test cases we are going to execute, but how we are going to do it, and most probably when we are going to test it. So let's move on. So to understand this, let me go back to our manufacturing example of cars. Right? When they build cars, do they build expensive machinery so that they can test all the aspects of the car once the car is produced? No, right? They don't do that. So similarly, we shouldn't do it. We don't need to write automated tests to test all the aspects of the software once the software is built. So if we follow that strategy, that is where we are going to get stuck. Right? So let's change the strategy. So when you are building a car, you first build the parts for it, and then you have machines to test the different aspects of those parts. Similarly, you can, when you are building a software, you can write functions for the core functionality or methods, and then you can have automated tests to test different aspects of those functions. Since we are testing a very small unit of the code, let's call them unit tests. And then once you have those the parts built for a car, and you have tested, and you know that those parts are of the desired level of reliability, you basically get those parts, put together, and come up with a component. For example, you can combine a lot of parts to have a component called engine or a cooling system. Right? Once you have the component, you have machinery to test these different aspects of this component. Mainly what those machines are testing is how these different parts interact and how they behave. Similarly, we can do the same thing for software. Once our units, the functions have reached the desired level of reliability, we can combine those things to build components. So it could be classes, modules, or you can call it different names based on your tech stack or development architecture. Right? And when you have those classes or modules, you can have automated tests to test different aspects of these components or modules. Right? And they are again testing the integration of these modules and how they behave. Integration of these functions or units and how they behave together to achieve the desired goal. Right? And since we are testing this as how we are testing the interaction and integration of these parts, we can call them integration tests. Right. Now coming back, once you have the components built for a car, and those components are of the desired level of reliability, we put together the components to come up with a complete car. And then when we have special machinery to test the holistic aspects of the car, like the performance, the look and feel, all these. Similarly, we can apply the same concept to software. Once we have these modules reach the desired level of reliability, we can put together these modules to come up with the complete software. And we can have automated tests to test the holistic aspects of the software, the performance, the look and feel, the scaling, things like that. So we are basically, when you look at the software, we are basically providing some inputs at one end of the software and verifying the outcome at the other end of the software. Because of that, let's call them end-to-end tests. And so let's take a step back and look at the big picture here. So we have many units and many tests for it. And then we have some components or some modules and some tests for it. And then at the end we have one software and some few tests to test the overall end-to-end process of the software. Right? So the word I used, many, some, a few, are relative terms. For one software, some could be like 100. For another, some could be like 10,000. So this is the concept that they are illustrating in the testing pyramid. Right? So at the base, where you have the widest area is actually covered in unit testing. So you have lot of functions, methods that is covered in there, and then you basically combine all these units to build a component or module, and then you have something called integration testing, or in this case, in this diagram, it's called service testing, because that's another way to look at them. And at the top, once you have everything combined, both these components, you have a single software, and then you go from one end to the other to do end-to-end testing, or you use the UI to test. So this is the testing pyramid. But interestingly, there's another way to look at this, and this is that. So you can look at the software as different layers and how you apply the different tests. So at the core, you have the unit test, and you build around the core the interactions, and you are having the integrations tests around that. And then on the outer shell, basically you have all the UI elements and all the functionality, the end-to-end functionality we are testing. Right. So let's see, so we have come so far, and we have figured out a model to improve our ourselves, but let's see whether we can improve this further. Right. So on one side, we have people called software engineers. They are highly skilled, they write code, they build software. The software addresses a business requirement, and the software delivers a functionality for the business. On the other side, we have automation engineers. They are highly skilled, they can write code. The code basically tests the software we build, and the software basically verifies the code they are writing verifies the fit to business use for this software. The testing, the subjective test, and that delivers reliability. Let's highlight the differences. It's not that much, right? So can software engineers double as automation engineers, or vice versa? If we develop the skills, yes, we can. So let's zoom in a little bit and see how typically we do the development, right? So let's say the person we are interested in has actually developed the skills to write both the production code, the code for the software, business software, and the code to test the software, the test automation. So this engineer, let's take one engineer for example, and this engineer has the skills needed developed, and he'll be coding. He'll look at the design specification and write some code, and that will basically build the software, and that's the first part. And then once you have the software, you basically go and look at the requirement specification, write some code for testing the software, and that is the second part. Remember, we discussed that this is not happening at the very end of the software process, but as we go along, because we now have separated our process into multiple stages, the units, the integrations, and also the end-to-end. Right? So this is, I'm talking about a single layer now. So seems to be good, but can we do something better? Writing code, a lot of code. Right? You have to write the code to build the software, and then you have to write the code to write a program to test the software. So it's very tedious work. Let's see whether we can do something to simplify it. To simplify that, I'm going to borrow a concept from SQL. Right? So if those who are familiar with SQL and who knows the concept behind SQL, we never specify what to do in a SQL query. Sorry, how to do in a SQL query. We only say what I need. For example, I say from this data set, select and give me these attributes. So we specify what, not how. So if I try to adapt this same concept to this and call it, I can call it executable specification. Right? I will say what I need, I specify what I need, but I don't say how to do. So there are tools we can use for this, but let's try to expand on this topic. Right? So if you try to bring in this concept, executable specification, to software, the business software side, we sort of have certain things, right? The business rules are very complicated, or complex rather, and the specifications is going to be very complex. So it requires like a lot of thought to be put into this, and sometimes the specification you can come up with is going to be worse than the code you are going to write, because it's that much complex, right? It's very difficult to specify some of the requirements in a structured manner, all the requirements in a single structure. So you will normally, what we do is we have different structures for different requirements coming, and because of that complexity, this requires a deeper discussion on designs and architecture, which is not the scope of this session today, but we'll probably have a separate session in future to discuss those things. So that's a topic for a different thing. But let's take the same concept of executable specifications and apply to the testing side. So testing rules are very straightforward, right? So you only need three things. You need to specify what are the inputs and what to test, the software or the unit or whatever the area, and what you are actually expecting from the interaction, like what is the unit supposed to do and what you are expecting as the output. So you only need three things, very simple if you apply this concept. So there are a lot of tools available, free and like commercial tools, that can handle the how part of it. So we only need to specify what we need, and the software, the frameworks or the tools can actually do the how part, they can do the heavy lifting. And the good thing about these three things, the inputs, the subject and the expectation, we can determine, or we already know before the product code is even developed or written, right? Because we can identify these things through specification or requirement documents, and then we don't need to wait until the end of the coding session to go and actually write these executable specifications for testing the software. We can actually type the tests before. Right? So a few benefits of doing that is, once you have the specification, you can always compare what you are building to the specification at every stage of the process. So you can effectively test the business logic in making while you are actually in the process, rather than wait until the end. And you can test whatever you are building iteratively while you are building. And also the third benefit is that if you are trying to do something and change something you already have written for the software, since the specifications are already written down, it can actually tell you that the change you did actually is going to affect adversely to a different behavior that you already have completed. So just keep these things in mind, and we'll come back to these points again in like a few minutes. So let's look at how we have come so far. Right? So sorry. Missed this one. So since we are bringing now that we don't need to wait until the specification, until the code is done to come up with the specification, we can actually interchange the steps. So just to go back, so we did the coding first and then we did the automation, and now we can actually interchange the steps and come up with the specification first and do the coding. So that's what gives us this ability to do test the business logic in making. Right? So let's look at evolution so far, what we have done. So we started with no automated tests. So let's call them like no test based developments. And then we came to a place where we have the test, but only at the end of the coding session. So that's test last development, just to give it a name, right? TLD. And then there's the test first development, which we talked about. We write the specification, but before the production code is written. And the fourth step of the evolution is called test driven development. So let me try to dig into these points a little bit further to set the background for the fourth point, or the fourth phase of the evolution. So when you don't have tests, you basically need manual testers, so maybe an army of testers, right? And when you have the test last process for development, you go ahead and do the testing at different stages, but always at the end of the session, right? And then when you have the when you go forward and move on to the test first development phase, you can actually build the executable specification for the test and then write it before the production code is there. So TFD has basically two repeatable steps in this process, right? So you write a test and then you write the production code or the software code until all these tests you have already are passing. Right? You write a single test, but you write the production code until all your tests are passing. So you can't accidentally break another test that you have. So you have to keep running all the tests every time. And the TDD, so what does it bring? So it's a very minor tweak to this process, but the effect is very big. So TFD stops when the tests are passing. So the second step, write the code until the tests are passing. But what TDD does is, it adds the third step. So once the tests are passing, now that you know your code works, and you can actually go and try to improve the structure of the code. So we call it refactoring. So by definition, refactoring means changing the structure of the code without changing its functionality. So we have three steps in TDD: write a test, write the production code until all the tests are passing, and refactor the code until you are happy with the structure of the code. Right? So pay attention, it doesn't say the production code here. So that's a very important thing in TDD. So there are instances where you need to refactor the tests as well. So this is what this diagram explains, right? So when the tests are failing, initially when you write a test, since you don't have the code to cater to that test, the test will fail, and normally the testing tools will indicate it in a red error message, right? That's why it's called red, the red phase. And then you write the production code so that all the tests are passing. So that gives us a green light. The framework says you're green. So that's the green phase. The third one is called refactoring. Right? So we try to improve the structure of the code. So another good analogy I found is to think about it like this. So the red is where you set the expectation, where you write the specification for the test, and then it fails because you don't have the necessary stuff done. And then you go on and actually build the stuff you need. So you actually invest your time to write the code or build the thing that you want to test or certify that particular behavior. And then once you have it, you have to do the cleanup work. So that is the refactoring part. So once you have the thing working, you can clean up your code so that it is more readable, easy to maintain, and looks nice. So I just want to mention this for the sake of completion. So when you're practicing TDD, like, it's good if you can follow these three rules. This basically encompasses like the real essence of test TDD, and keeps you from sort of moving away from the core ideas of TDD. Right? So this is not the the 3 stages, but 3 rules defined by Uncle Bob to help us keep our structure and like do it in a very methodical manner. So let me have a quick time check. Right. So this, I'm going to skip this. This is just a comparison between TDD and a scientific method and ideas about the advantage of TDD. So this TDD approach basically encourages incremental and iterative development. So if you look at like we do build part by part, so it's the same thing advised by agile software development methodologies, right? So it forces you to basically work in small iterations and work at one requirement at a time. And then it gives you the ability to refactor with confidence. That's the third step of TDD, as well as that is what gives you the freedom to usually like have the confidence to go and change the code without being worried about whether I'll break something, because if I break something, I will immediately know. And it helps us with coming up with a better design for software, because since we are starting from smaller units, we'll think how to actually organize these things properly, have a better modularization, and have a good interactive interfaces maybe, and a good architecture. And also it forces us to think like what is the code, this particular code is going to do, and how I'm going to test it, how I'm going to verify it. All these things you have to think before you actually go and write the code. And also it helps you or forces you to clarify the requirements, because you need to understand what the inputs and what the real expected behavior you want to get out of from this. So once you understand, you are better off writing a good piece of code or software. And it gives you like faster feedback loops and smaller, because we don't need to wait for somebody else to come and test our software. We already have the test specifications that we can immediately execute and see. And another good thing is like it actually documents your code. So if you look at, remember like the structure of a test, it's very small, like only 3 things: the input, the subject, and also the output. So it's very simple documentation, very readable. And also like if you look at a software, like 60 to 90% of the maintenance life cycle is basically life cycle of the software is maintained. Yes. So with this, what TDD delivers is like a regression suite, test suite, right? So you can always run it to make sure that whenever you do a small thing, you don't accidentally make something else. And also it can act as a safety net. So as I said, like if you break something by accident or intentionally, it will tell you, okay, this is where it's broken and you need to fix it. And so TDD, what another thing gives is like people who are like encourage or advising going for unit testing and other tests. TDD gives you better coverage because you start with the test rather than the code. Because always, if you have the tests coming after the test code, you might not go for 100% coverage or something closer at least. So I think I covered these things: faster feedback loop, the interface designs. Again, like it gives you, it forces you to like focus, instead of focusing implementation of the code first, you first think about developer experience. That's where the good user interfaces, good interfaces between objects and code comes in. And also it encourages the simplicity and not to overdevelop anything. So anything you don't need, you are not really encouraged to develop. Right. Cool. So before moving on, let's try another exercise. So if you go to Slido again, and then there's a small survey. You can type what are your concerns about. Let me try to address some of them. don't see any answers coming. Is it something wrong with me? Can someone verify?
No, you're perfectly audible. Ranga,
Yeah, okay, cool.
we can hear you.
Right. Alright, cool. I'll expect some things to come in soon. But let me, I've identified certain things as well. So let me go through the list without waiting. So, I mean, like anything else we can actually address in the Q&A session as well from the development process, right? But the way I see it, churning out code as development, right? If you think development is the holistic thing that you need to do to make sure that write some functionality and then make sure that functionality works, it probably speeds it up because you are doing it in a single go. But on the other side, there is upfront cost. So you need to set up the process and the technical frameworks. You need to train the engineers, the mindset and the skill. And also you need to get the buy-in from the management. And there will be a grace period where you will see a slow output because not because the practice is wrong, it's because people are not used to the practice. It will take some time to develop the skills to go faster, but at the end you will see a real ROI or return on investment of your time and the cost, and you will see that the team's confidence will rise so that they will be up for any challenge, the development work or the code base they have, because they are confident that if they and another sort of a spin-off argument from that is also concern from that is it will delay the project launch. For that, actually some people suggest something like this. So they're saying that you can go and always add the test only if you want to change something, right? So just before the change, not when you are developing. But as we discussed, the change is the essence of business software. If it is not changing, it's not really a business software, right? Because the business always changes. And then adding tests before a change is not a TDD practice, it's a different practice. So that's out of the scope anyway. And but another problem is like if you try to add the tests when you are going for change, you need to first understand the code to see what it's doing and then go and edit the test. But if you already have the tests, because at the time of development you already understand what the code is supposed to do, so it's very easy to specify what the code needs to do as a test. And another thing is like if you plan to do the test at the end, you might not go ahead and cover all the scenarios that you can think of because you are only focusing on something. But at the time of development, you are actually building the software based on the test specifications you are writing. So the functionality will come as a test obviously. Another concern is about job loss, which I am not going to do into detail because I have very lengthy notes on it. But like if you take an example of like alright, cool. Sorry. If you look at example, so one concern is, right? So nowadays in Sri Lanka you have like this cash recyclability. Can you hear me, bro?
Now, yes.
Was dropped out.
Yeah.
Okay, I was dropped out of the call.
Now I can hear
Let me
you.
quickly share my.
There was a like you are kind of breaking up badly.
Okay,
Now it's fine, I think.
damn message. Okay, right. Let me quickly share my screen.
Sure.
Okay, I hope you can see it.
Yes.
Can somebody
Yes.
confirm?
Yeah. Yes.
Alright, cool. Right. Yes. So, like the concern about testers losing jobs, right? So, if you look at a similar industry, like a different industry, let's look at banking, for example. Now that we have cash recycle machines, we don't really need to go to the counters to deposit our money or deposit checks even, because some machines actually accept checks, right? So, the teller's role, as you know, is disappearing. But did people lose their jobs? I don't think so, and I have not seen any examples of it, because what will happen is when the machines come in, the humans will be used for something that humans are good at, thinking and planning stuff, right? So they will be assigned to other areas where they can contribute more rather than being a mechanical worker in organization. So that same thing will happen to the testers. They are like the testing and all that is like a very huge area. I mean, they can actually move on to doing something more valuable like the exploratory testing, and also other areas of quality engineering, which is like an even bigger area. They can move more forward, right? On the other side, there's, I mean, like there'll be always things that are coming in new and requires manual testing. And sometimes we don't need to go for automated testing at all, because it could be certain things that are one-off, and like something like very fairly static, you develop something and you leave it. Also, you only need to test it once. And also there will be like urgent outsourcing requirements where you need to hit a like a certain market timing, so you need a lot of testers to do the work. So the way I see it, it is like a very unlikely thing that will happen. Right? Another concern is like TDD is very expensive, right? So for that, I'm not sure whether I have the slide. No, I don't think so. But if you look at how costly a bug in production is, it's comparatively like tenfold or even more, right? So test TD is probably expensive from the looks of it, but it's always better than having a bug in production. And some concerns is like waste of time and effort. Again, it's a waste only if you don't use the test suite you're building. So if you use it, I mean, it's always worth the effort, and it's a lot of more work. Yes, it is, because you are doing two things, not just one, not just the coding. You are also doing something for the testing. And another concern I've seen is like the lock. It locks design. On the contrary, actually, it actually frees up the design. Where it gives you better architecture, better design if you practice it right. So all these concerns are not really valid. Let me quickly have a look at what else from the Slido. So what is the future of testing? Okay, let's take that up in the QA session. Can TD cause scope creep beyond what is acceptable? It probably can. Let's take up in the QA session. Yeah, so let's quickly move on to the last part I want to discuss. Let me quickly take the time. Alright. Yeah, so again, a Slido. So why do you think that people are not practicing TDD? So like the 14th annual State of Agile report I saw recently tells that they have like various metrics, but this was one particular page saying engineering practices employed. So 67% of people are using a unit test, but only 30%. Even less than half is using TDD. Lack of time, right? Initial investment of time to get started, yeah, good. Makes it more complicated. Interesting. Cool. Lack of understanding, alright. So I will go through the details, but keep your answers coming in. We'll take up some things in the Q&A session. So here I will probably not go through all the list here, but so the first thing is the concerns about it. So it's basically you are fear driven, and because of that you don't want to practice. And some people say that it doesn't really solve their problem. So my take on this is practice never solves a problem. It only improves the process, right? So what TDD really does is it cuts down some steps in the development process, make it more efficient to iterate, and introduces sort of an effective way to develop software, right? So practice is something that you need to develop as a habit. So that's what I recommend. Even if it doesn't solve your immediate problem, it's a practice that will give you a benefit over the long run. So form a habit. And company management doesn't give us the time. So this is the number one reason I hear from interview candidates. I know TDD, but the company doesn't give me the time. So it could be related to the slowness concern that the development process gets slowed down because of TDD. But the way I see it, it's just like passing the ball, right? So I'm not taking responsibility for not doing TDD. I'm just passing it to the management. So the problem I see this is like if you are software engineers, you are hired as professional, and a professional has a say in the matter, right? For example, if you go to a doctor and ask him to prescribe something to you, they will not just prescribe something directly, right? So first they will actually check whether there's a reason to prescribe, and they might actually refuse it. So if we are professionals, we need to do the same. So if somebody tells you not to do it, okay, we don't need tests, just do it. And if we really see that we need to do it, we can say no, we have to stay on our grounds and say no, we need this because these are the reasons. So we have to be very polite, but we need to stand our ground, right? So normally what happens is like normally the software developers, I mean, like we refer to ourselves as geek, right? So the geeks are not really good at communicating. They're very good at technical stuff, but not at communicating. But on the other hand, the managers are quite good at communication. So they sort of get upper hand because they can try to like manipulate the words in such a way that you sort of somehow agree to like abandon the thing you want to do, but follow their sort of direction, basically. Right? So there is solution to that. That is, you need to figure out how to present this as a win-win for the management. Once the management understands it, they will really see the value and also encourage you to do it. So there's no you should not really shy away from the responsibility. So you have to actually take the responsibility and be professional with it. And another thing is like, I'm a great programmer, I don't need TDD. So it's a very frequent one I've seen from some people. And it's like saying like, I don't need seat belts, I can drive without getting into accidents. Right? Total bullshit. Okay? The tests, the way I see it, the tests are really a safety net. And the tests are not just for you, it's there for the team. So tests can actually stop someone else accidentally breaking your code. So you might be a great programmer, does it? But somebody else might not be. So it still saves your code at the end of the day. And just to quote a couple of quotes from Ken Beck. So the first one he says is, optimism is an occupational hazard and feedback is the solution. So this he describes in his book called Test Driven Development by Example. And another quote he has made somewhere else. He says, so Ken Beck is regarded as one of the greatest programmers in the world. But what he has to say is, I'm not a great programmer. I'm just a good programmer with great habits. And the number one great habit he has is TDD. He always does TDD. So like to this concern or the reason for not practicing, there is a solution, and that is, so this is hard to bite, but you have to let go of your ego and you have to be a team player. So might be a very great programmer, but you have to play a team game. And then another thing is like tests should be written by others, possibly. Yes, sometimes it's valid. So it has another variation which is a longer one. It says tests should not be written by developers who write the code. They should be written by others, possibly QA people or somebody else who's more into looking at the quality aspects or the business aspects of the system. And another shorter version is like we have a QA department, writing tests is their job. So you're just trying to pass the ball, right? But if you look at the way I see it in this street, like it's the developer's job to write the code that works and that he can prove working. So the proof actually comes from the tests, and doing the TDD is the easiest way to get the tests ready. So you can easily prove that your code is working. So another thing is like whenever you do the coding, you have to test it anyway. Right? So would you prefer to rather do the testing manually, or have the executable specification done before, so that you can run it as many times as you want without wasting much of effort? So the solution for this reason, the way I see it, is like understanding the responsibility you have to practice it the right way. And another thing is like the code is not testable. Right? So some people go and say like the previous developer has created a mess. There's nothing I can do. The code is simply untestable. I can't do anything. Do I want to do it? I can't do it. So it's again a way of passing the blame. So those who are, some of you might be already familiar with this concept, the broken window principle. So it says that like the crime rate usually goes up in neighborhoods where there are broken windows. Right? The reason being that it looks like the people don't really care. If you have a broken window, you usually go and replace it. Right? The same thing goes with TDD. So the more untestable code you have, it looks like nobody really cares about your product or the code base. So what you need to do is show them that you really care, and the next person will be more careful rather than just increase the mess. Right? And also, like even if you have a very messy code, there are ways to untangle it. So I can recommend 2 books for you if you want to read and understand. So the number one I would like to recommend is the book by Michael Feathers. It's called Working Effectively with Legacy Code. It has some strategies how you can actually get tests into a code base which is messy. And also another book by Martin Fowler, Refactoring. So that actually gives you the core ideas behind refactoring, how you incrementally do it, and it gives you very methodical ways of step-by-step instructions on how to do it. I mean, they call it baby steps actually, right? Very small steps, so that you can't simply go wrong. And also there's another thing I can recommend from Martin Fowler. So it's a blog post, and I'll probably share the link with you a bit later. It's called Strangler, where you can actually implement this pattern. So as a way of getting more tests into a code base that is already messy, right? So again, the solution for this concern is basically taking responsibility. And let me quickly check the chart. Alright, I have a few more minutes. So let's try to quickly go through this. I want to come to the last slide. So everything is not testable. So similar to the concern saying like the code is not testable because somebody else made a mess of it. And another claim is like everything is not testable. And also like I've seen certain variations say the functionality I'm developing is not testable. And also setting up the test potentially with the mock stubs and all the stuff is a lot of extra effort, and it's very difficult. Sometimes it says it's very difficult to simulate a certain scenario. For example, like you want to test a 100 MB file upload, so it's not very easy to do it every time, right? But for these things, if it is really hard to test, it's something wrong actually. So it could be a design no architecture problem. It could be your testing approach, or it could be that you don't really understand how to test it. I don't personally believe that anything you develop that you can't say that you can't test, because it's something you are developing, right? Not that something somebody else has done. So it's you are building something and you are saying that you can't test it is not a valid claim. And also there are like a lot of tools like standard patterns like MB patterns, and also like other design patterns that you can use to help you with the improving the design of it so that it's more testable. And also like usually the UI parts are very tough to test, but if you do it in a proper manner, design the software in proper manner, you can actually skip that layer, UI layer, and test the behavior or functionality of all the software like if you plan it properly. And also there are mocking frameworks that are available that can actually mock away the external frameworks, external dependencies, so that you can test your core of your application. So the solution for this reason of not practicing TDD is basically to understand the design and architecture concept and focus on that, so that you can improve your the code base and the tests that you are putting in. And I will tie the tests at the end. Okay, that is not TDD, so I'm not going to details. And this is not a POC. This is a POC, and no need to write tests. So on that, actually we need to double check, because how many times we have seen that POCs actually become end products in the end, right? Because it keeps going through multiple cycles of user feedbacks and then becomes the end product. So unless you build the tests in it, at the end, if you want to edit, so it becomes very hard. So one practice people do is actually one thing you can do here is actually insist on TDD, even if it's a POC. The second thing people actually do is if you are really sure it's going to be a POC, you inherently build a limitation so that you can't actually go for a full solution with this. So you are forced to do a rewrite, and with that rewrite, now you understand the product better, you can start with the TDD. And another thing is they take a lot of time to run, so it's actually a problem with the tests, or how you run. Rather, you have written the test, or could be something wrong with your design, so you need to improve on that. Okay, so my clients don't care. Okay, interesting one. And it's like saying my clients don't care about the code as long as it works, and you're saying, okay, I don't care because in future this code base is going to be somebody else's problem, and that somebody else could be yourself 1 year down the line as well, because if you stay in the same company or serve the same client. So what I recommend is be professional, follow good practice. And this is the last reason I want to discuss, and this is the only valid reason I would say that why people don't practice TDD, because they don't know how. Because we don't have any professional courses really going very deep into TDD, especially in Sri Lanka. And I don't know about any of new syllabuses, but I haven't seen anything about TDD in university courses at all. They might have changed recently, but I haven't seen for quite a few years. So we need some professional training actually, because everybody's whoever's not doing it is actually coming into new, and it requires a special set of mindset, training, practice, and also time investment. So it will take time, right? So what I can offer you is to understand the basics. If you can read the Test Driven Development by Example by Ken Beck, it's a good start. It's a very good start. And there are some online courses I have seen, and from people like Eric Elliott. So that's on JavaScript. But there are good courses, and also if you search YouTube, you can see some videos. But you will take some time to understand. Well, it's very easy to understand what they are doing, but why they are doing and how they are doing, and basically to build the mindset, it will take time. So invest time. Right. So the problem is with the wrong reasons. So there are wrong reasons to adapt TDD, and that is, quickly check the time. That is, one is that you are actually trying to catch something shiny so that you can put it in a CV. So that is the name people give, resume driven development. So it's just to fill in your CV, right? And some people practice it as a silver bullet. They think of it as a silver bullet to get rid of technical debt, because it's sort of have an emergent design and evolutionary way of building software. But the problem with that is there could be hidden technical debt coming at each stage of TDD when the testing, writing the test, doing the coding and refactoring. So you have to be very careful when you're doing it. So it's probably the wrong reason to go for TDD. And some people say, like, I don't need to go for analyzing the solutions, designing, because with TDD I can incrementally build it. Right? Again, if you don't have a plan, if you don't know where you're going at the end, I mean, you might end up somewhere else that you don't really want to go. Right? And also, another thing some people have said to me is basically like, I do it because my company needs me to. Yes, it might be good, but the problem is that you don't really understand why you need to do it. I mean, it's in their structure, it's in their process. Yes, you do it, but it's the wrong reason. So let me go to the right reason. This is what I want to really discuss. And before coming to that, I'll tell you what is the problem with wrong reasons. The problem is that if you buy into any of these wrong reasons, you will not practice it right. To get to the right results for TDD, for a practice like TDD, you have to practice it consistently, right, throughout the time. Right? It's like going to the gym, right? So you can go to the gym for the wrong reason, but if you want to get the right result, keep your body in good shape, you have to do it consistently. Right? It doesn't mean every day, for example, depending on your schedules, but you have to do it consistently. So the consistently only comes when you understand why you are doing something, a practice like this. And the why should not be logical. We build a case for logics and we understand totally, but it doesn't work unless you have an emotional reason to do it. So let me take an example to describe this. I'm pretty sure you, almost all of you have seen this, right? At hospitals we have seen it. We know it. They do. And why is that? Can somebody respond, please? I saw a refresh. Niro, can you hear me?
Yes.
Alright, go. Let me go.
Yep.
Right. So, the doctors don't practice it because the hospital demands it. Or they were taught to practice it, like at medical school. Or because it looks cool. Or just because it's also germ problem. Right? They do it because it's part of their professional code of ethics. And honoring the code of ethics it's like I'm having issues with the network. Can you hear me?
There's a bit of issues. Connection is kind of breaking up.
Sorry guys, my SLT is giving me troubles. Can you hear me now?
Yes, now I hear you.
Okay. So last slide, let's try to complete it soon. Let me cast this. Right. So doctors practice it because it's part of their professional code of ethics, right? So that is the reason I'm trying to hone in, right? So if you just take one right value, if you do it, then why you are doing it, and the why has to be emotional, not logical. Did you hear me, guys?
Yes, sir.
Yes, sir.
Yes.
Okay, cool. Let me
That's
just
fine.
repeat in case if you didn't, right? So if you take just one thing from this entire session, take this. Right? If you want the right value from a practice, you have to do it consistently. And consistency only comes if you understand why you are doing it. And the why has to be emotional, not logical. Right. So moving on, the right reason I suggest that we adopt is basically the professionalism and the code of ethics, right? So software engineering is a profession. Right? We do something other people can't do. We basically build the things that runs the world. And we have the power to change the world. And with great power comes Spider-Man, great responsibility. Right? So we have a responsibility to have good practices to ensure that we do the right thing. Right? So the practices we are talking about is something that established, well accepted, that produce a procedure of good conduct, and also that encourages accountability or improves accountability of our work. And also the code of ethics I'm talking about is basically a self-assessment that if you break your ethics, you will know, right? You might be a very evil person and decide and go ahead and break your code of ethics, but normally not. People don't want to do it. They really understand if it is emotional enough. So that's what I'm suggesting that you build around this practice of TDD. It has to be some integral part of your code of ethics, right? So just to give you a hint, like we talk about the doctors and their code of ethics, just for washing hands, something other than that. So we have a similar professional called accountants. They practice something called double entry, right? It doesn't really do much. It's a very simple thing, but that is in part of their code of ethics. You can't find any accountant who doesn't practice that, because as an accountant, it's part of the ethics. So that is the level of TDD or practice like TDD we want to go for. In professional software development, it should become a part of a code of ethics. So that is basically what I want to discuss, and let's see whether we have any questions and answer. Okay, I have a few more slides, but I will not go through those things. Yeah, cool.
If you have any questions, please put them on the chat, everyone. We are happy to answer them. Thank you, James, for the comment. Appreciate it. So this is an opportunity for anyone who has a question or any concern that you want to quickly discuss.
Yeah. So let me try to go back to the other answers as well.
Sure.
While we Alright, so lack of understanding, I think it goes along with the thing I said, like they don't know how to practice it, that's why they don't know to practice it. So it is very, so these are the answers to why don't people practice TDD. So TDD is very dynamic and when it compared to TFD, so it takes time to get adapted. Yes, that does. So that is just going to be an initial time investment, and most of the investment actually goes into building your mindset. So practice is very easy, but it will take some time to really ingrain what that practice really means. But once you see that, your whole world will change. I've seen it happen in people, and they can't. It's like this, right? There's a saying that a mind stretched by a new idea doesn't gain its original dimensions again, right? So it's just like that. So once you really understand what TDD delivers you, what it does, and you will never be able to look at any other things like basically. You will not be able to look at software in any other different way. Makes it more complicated. Why don't people practice TDD? So on that, I don't really believe it's complicated. It's just that it's too simple that it's very, like if you don't really think about it, you don't understand. And more than thinking, I think you need to practice it. So if you look at the steps, it's very simple, right? Anybody can do it. The problem is unless you really do it for consistently for some time, that is the time investment I talked about, you will not really gain what is that. And once you understand that, it's very simple. It's like walking, right? So if you have seen a kid, how many times they fall down? It's very complicated for them to like stand up and walk. But once you get the hang of it, it's not that difficult. It becomes second nature. Same as riding a bicycle, right? So it's very simple concepts. Until you figure that out, until it becomes your second nature, you feel it very complicated. But once that happens, it's very simple. There's nothing to it really. If I ask you to teach me how to ride a bicycle, it's going to be very difficult. Because it's not something you can teach. It's something you need to practice. So TDD is like that, the way I see it. Initial time, investment of time to get started. Yes. So that's a good question, a good concern, reason. So the thing is, like I've seen is something I've seen is basically people are waiting to get the opportunity at their work to practice TDD. And because of that, not many people do it because they don't get the time to do it. So the practice, it's like waiting until you get a race to practice how to ride a bicycle. That never happens, right? So unless you practice, you can't get into a race. Well, you can get it, but you will not ride properly. So it's like that. So waiting until you get opportunity from your job to do TDD is the wrong way to do it. It has to be something coming from you. You should do it because you want to do it, not somebody else wants you to do it. Yeah, the lack of time. Yes, so that is the time investment that you need to figure out. Just because we lack time, we don't say that, okay, I don't have time to eat and I'm going to starve fast for 3 days. We don't, right? We somehow find the time. Could be just a small snack. So think of it like that. Take a small snack. Practice TDD for 5 minutes a day, 15 minutes a day. So we will probably have another session, maybe in few months, where we discuss about how to do the TDD, where we talk about the katas, for those who are not familiar with the things. So kata is basically it's coming from karate, so it's just way of practicing something. So there are small exercises that you can do, 5 minutes, 10 minutes, 50 minutes, and then it's very fun to do. It's a repetitive thing, so you can try different variations of your coding every time, and that gives you the practice you need. So just ideally, if you can it's great if you can spend about 30 minutes per day to practice that. Even 15 minutes is enough once you get hold of it. So you should start practicing the smaller stuff before you actually go into practicing TDD at your company, because that is a whole different level of TDD. Unless you really understand what TDD means to you, you will not really do it properly. So that's where the consistency comes in, or the practice comes in.
We have one question on the chat.
Yes.
From Sanjeev.
Is TDD only effective in a cross-functional team? No, not necessarily. So, just give you a personal example from very long age ago. I actually used to pair with another developer. We were building a fun project. It was not a company thing. It was very long time ago. We are not going to sell it, and we were doing TDD, right? So basically, the way we were rotating. So he was writing some code, he was writing a test, and then I was writing the code for it, and then we switched the roles. Basically, so just two developers. We were building something for fun. It was just for fun. We didn't sell it, we didn't like advertise it, and nobody has seen it properly as well. But we were just experimenting with the language and like trying to do interesting stuff. So this same concept you can apply to any other place. Like it doesn't need to be a cross-functional team. Just 2 developers can do it. Or you can do it yourself. You don't need anybody else. For example, if you are doing on a solo project, you can play. I mean, like doing it in a team is more fun, because that's why I remember that experiment. Like because we were just switching between the seats and the machine. Well, not laptops even, like the computers we had all those days. So it was very fun because it was a team thing. So team, if you do it in team, it's very fun. But even if it's not a team, still it will deliver the same value. So there are other things that we can probably discuss further, like whenever you are doing a TDD session, like where to stop so that you can park it and come back the next day. Like those things, like the fine-tuned stuff that you have to practice. So we can discuss further if you have more questions on it.
Also, it's kind of the starting point is the mindset as well, right? So it's a mindset,
Yes.
how you think of what you want to get done.
Yes.
So you start kind of changing the way you think. I think that's where it starts, right? And there was a question about the complexity, right? I think TDD is a solution to reduce the complexity, right? You think of the smallest functionality that you could output, and then you start implementing TDD, right? So that's where there was a principle called KISS, right? Keep it simple. So that's the principle.
Yes, and the other one is the Yagni one. So you ain't gonna need it. So basically, you don't develop anything that you don't need, because you are driven by the test. Your code, the work you do is driven by the test. So unless there's a failing test, you are not going to write any code. So let me go back to Uncle Bob's 3 rules. That's why I said, like, when you're really practicing it, I mean, this makes it your life more structured. If you look at the third one, you are not allowed to write any more production code than it is sufficient to pass one failing unit test. So you can't develop any functionality that doesn't come in a test. And the test comes actually from the requirements. So life actually becomes simpler. I mean, if you think the way, if you keep on thinking about it, it looks very complicated. But if you start practicing it, it's very simple.
Looks like we have
so simple that it's very hard to understand.
Sorry.
Yeah, it's so simple that's why it's hard to understand. I mean, probably the simplest things are the hardest things to understand, right?
Yes, certainly. Ananda, looks like there's a question from Kasun on Slido.
Okay, I don't know how to switch to Slido. I'm quite new to Slido. So maybe you can read.
Yeah.
Can you read?
Kasun, you are there? Maybe we'll ask Kasun to read it.
Yeah, hi Ranga. So what's the difference between TDD and BDD? So that's the question that, yeah.
Alright, so it's just a name the way I see it, right? And BDD is more or less a style. So BDD means business driven development. Oh, rather, sorry, my bad. Behavior driven development.
Yeah.
So it talks about like how you specify your requirement as a behavior. Right? So once you specify it, it is actually a test, right? So the only difference is like we didn't want to make people worry about too much technical stuff. We simplified a language, like we call it BD style or Gherkin style.
Yeah.
Like we have a very simple language that they can describe the specific requirement. Yeah, for example, you can say when I am doing something, when I am at this place in my software and I do something like this, then I am expected to see something like this. So anybody can understand. We develop BDD just because the managers can read and understand. Non-tech people can read and understand. And probably they can help us write those things. When it comes to TDD, It's the same thing. We take the same thing and we can run it because we have a framework behind that can actually look at that, convert it to a programming instructions and execute it. Give me a minute. So if you look at some popular, so BDD style, gherking is not the only style. The styles are like, you have like the sorry, I forgot. The Jasmine style, for example, if you say it can do this, and you can go ahead and describe, and I'm expecting something like this. So this is sort of again like building that particular jargon that somebody else who doesn't really need to understand how to say like a point to some object and call a method in the object can write the same thing and still read and understand. It's just a matter of the way, the level of abstraction for the specification. It's another set of words, I would say. The practice is really, BD is just a style. Did I give you a good enough answer? No, do you have more questions?
Thanks, Ranga. Yeah, you did. So
Cool. Alright.
Do you have any more questions?
What is the future?
Okay.
Yeah. So, what is the future of testing? So, interesting question. Testing is going to be always there because we need to test. It's just that the who will test it and how we will test it will change. It's like when people were, when before the time of Henry Ford, people actually go to different places. But after Henry Ford, the way people go to places changed. They use a car or vehicle, but still the need to go to some other place is still there. The testing will always be there. It's that how we are testing will change. It's very similar to how we work now, right? We work remotely. We still work. We still get paid. We still probably, maybe we do even more work now that we are at home. But the work is still there. Nothing changed. It's just how we do the work has changed. Can TDD cause scope creep beyond what is acceptable? I don't think I really understand the question, but let me try to answer it, and also you can, maybe you can actually, whoever read that, would you mind turning on your microphone and describing this further? Okay, let me try to do answer this to the extent of my understanding, and then if it is not correct, you can comment on it. So scope creep is never a problem of the practice. TDD is a practice. Scope creep is a problem with the requirements pipeline or the business or how it is managed rather. Right? So it's going to be always there regardless of the practices you are employing. So it should be handled at a different level. But what TDD will allow you is to have less stress when you have scope creep, because you know that you can modify something and you will know if you break something else. So scope creep, you are better prepared to deal with scope creep even if it comes, if you have TDD. I don't know whether I gave you a satisfactory answer. Somebody can comment, whoever added that can comment. Or do you have any further questions on it?
Looks like it's fine. So maybe around we'll go for one more question. Anyone?
Sure.
Do you have anything else pending in the list? On the chat we don't. That's basically.
Sorry Sanjeev, I forgot to check with you whether did I answer your give you a satisfactory answer on the question. Sergio Fernando, is TDD only effective in a cross-functional team?
Yes, Ranga, you did. Thank you.
All right. Cool.
Looks like that's it. So, Ranga,
All right.
shall we call it a day?
Yes, of course. So guys, like follow. I mean, soon you will receive a small survey from organizers, basically asking you to list down some of your learnings. So it's going to be very interesting for us to understand what you learn, and also I had some of the things like planned out. These are going to be the learnings. The reason why we didn't actually disclose that at the beginning of the session, or rather in the initial advertisement, is just to get your feedback, so we have more better ideas coming from you, so that we can like customize the talk another time when we are doing a second time also. But we are really interested in seeing your opinion on that, or to learn what you have actually took from this session. And following that, so once you reply to that, we'll actually send you the intended learning outcomes we had as well, and also the link to the recording of the session. So thank you very much.
Thank you, everyone. Hope to see you in the next session. Until then, take care.
Thanks, Ranga. Thanks, Hiroshi.
Cheers.
Thank you.
Bye.
Thank you.
Thanks, Ranga. Thank you very much.
Thanks, Aranda.
Thanks, Hiroshi.
Thank you. Bye.